Graphical summaries of qualitative data. As we saw in earlier section, data can be separated into two main types, qualitative or quantitative. Depending on what type of data we have, the way we summarize with graph or the way we graph it is different. So in this video, we're going to look at graphical summaries just for qualitative data, or also known as categorical data. Often data sets that researchers collect will include repeated items. To organize this information, they can use frequency distribution, which lists the distinct data value x along their frequencies, f. So frequency distribution, we can just think as counting. If I have several categories, within each category, how many of them do I have? Relative frequency of each distinct item describes the amount of item appears in a data set divided by total number of observation. If n is the total number of the items or category within a category, and x occurred f times. So f divided by n is the relative frequency. So the relative frequency we can think also as proportion. Whereas frequency distribution, frequency is just we're counting them. How many numbers do we have? Just numbers. Let me write that better. So let's look at an example of how to organize frequency and relative frequency using a bar graph. So in bar graph, the bars have equal width, and height represents the frequency or relative frequency. So in any graph, it's important to pay attention to x-axis and y-axis. So here, let's look at this. The frequency is the y-axis, and the category, or in this case, the body part for the rehab, types of rehabilitation, is the x-axis. So we have several categories: back, wrist, elbow, hip, shoulder, knee, hand, groin, neck. So for each of them, depending on how many of we counted in the data set. So for example, back, there are 12 people who had a back rehab. There are 2 people who had wrist, 1 for elbow, 2 for hip, 4 for shoulder, knee is 5, hand is 2, 1, and 1 for groin and neck. So we're just counting them. That's the frequency. And using a bar graph, the width has to be same, and we label each category, each data type, and the height represents the frequency. Relative frequency on the right side here, the relative frequency is percentage or proportion. And here body part is again the. So how do we get this number? The back right here is 0.4. So what we do is, let me just do this example. For back, we have 12 people who had a back rehab out of total 30. So what's 30 coming from? There are total 30 patients in this example. So if we can add 12, let me do that again. So there's 12, 2, 1, 2, 4, 5, 2, 1, 1. If I add all the number, I get total 30. So if I do 12 divided by 30, I get 0.4. So that's the proportion of back. And then wrist, I get something between 0 and 0.1. Well, I can actually divide. It will be 2 divided by, for wrist, it will be 2 divided by 30. Which gives me about 0.067 if I round it to 3 decimal. So that's how we get this proportion, or we call it relative frequency. And of course, if we add all the relative frequency, it should add up to 1, since it's a proportion. So we can even say that back is about 40%, knee is about 18%, shoulder is about 1.15, so 15%. And if we add all of them, we should get 100%. Therefore, if we add all the frequency, it should be 1. Pareto chart is a bar graph whose bars are drawn in decreasing order of frequency or relative frequency. So it's a parallel chart is just a type of bar graph, but it organizes into decreasing order. So in this case, the same example, we had a back has the most relative frequency, about 40%, then knee, shoulder. So this is easy to read the data. Because let me go back to the previous one. Here, in order for us to compare, which one has the second most? Well, it's clear in this case the back was the most. Which one was the least? Right, then we have to do some observation. It takes time to observe which one is the least, which one is the middle. But in parallel chart, is already organized in decreasing order, the most to least. Therefore, it's easier to identify which one was the most, which one was the least, which one was the middle. Side-by-side graph is essentially again another type of bar graph that comparing between two groups. So in this case, we actually have a relative frequency on the x-axis. That's totally fine. We can always change it. Depending on data, sometimes we want to present it this way. And the left side is education and attainment. So each category. And within the category, there are also two groups. That's the side by side. Two groups in this case. Well, of course, we can also do 3 or how many you want. Then it gets really complicated, but just know that it is possible. So here we're comparing two groups. So for 1990, people who did not graduate high school was about 0.25, about 25%. But in 2017, people who did not graduate high school was about 0.13, about 13%. So side-by-side graph is a bar graph comparing between two groups. So each category has 2 bars. Lastly, we have a pie chart. In pie chart, each category is shown as parts of a whole pie. So here we have education attainment just from 2017 data. And here, each section represents the category, and the size of the pie shows the percentage. In this case, because we're looking at relative frequency. So pie chart, there's a one negative thing about pie chart. That one could argue that because of it's oftentimes hard to look at the angles. I mean, here they give us a number, right? So we can compare easily. But if number wasn't there, it's hard to compare. Is this angle and this angle same? So because of that, it's not the most effective way of organizing qualitative data. But it's still used. We just need to know how to read it because there's some place for it. It's easy to organize rather than bar graph. It looks simpler than bar graph. But there's definitely some thing that we need to be cautious about because it's often not easy to compare each size, especially when these percentage numbers are not given.